Good morning, everybody. Welcome back to lecture number 30. So we finished op-amps. We finished basic circuit analysis up to chapter 5. Now we will talk about diode. Before we go, let's do our habit of reading about diodes. What are the diodes? So if you go here, let's look at the English page first. So a diode is a two-terminal electronic component that conducts currents in one direction. It has low resistance in one direction and high resistance in the other direction. So I'm assuming while it conducts current, it has low resistance. While it blocks current, it has high impedance or resistance. A semiconductor diode, the most commonly used type, is crystal piece of semiconductor material with p-in junction connected to two electric terminals. This is one of the shapes of the diode, but this one is transparent. Some other diodes they look like that. They have black material. Some they have transparent material. The diode was invented 151 years ago. It is not a new device. And it has two terminals, the anode and the cathode. Okay? Some of the applications, the most important one, it is used to convert AC to DC. That's how we convert DC and AC. Okay? Let's open the Arabic page. الصفحة العربية خلونا نفتحها يا شباب ونقرأ معلومات عنها. الصمام الثنائي. ثنائي المساري، ثنائي المسرى أو الثنائي. I prefer this name, الصمام الثنائي. Don't call it صمام, لأن if you call it صمام, you mechanical engineers have lots of valves. ثنائي لأنه it has two terminals. Okay? Again, I prefer you read this just for your own benefit, because especially the first part here, you don't need to have knowledge about it, okay? That's what I want you to know from Wikipedia. Let's look at some pictures. You can buy it. Very cheap. 6 riyal, 14 riyal. These are some of the shapes. Look like. This is the one that you will see in the lab, okay? Okay. So we're going to talk about what? Diodes. خلصنا. Okay? So in this lecture, in this chapter, chapter 9, which is not part of the major, we will talk about basic diode concepts, an ideal diode model, some of it today. After vacation, we'll talk about piecewise linear diode models, the Zener diode, rectifier circuits, wave shaping circuits, clipper circuits only. So rectifier is the application to convert from AC to DC. Okay? What are the goals of this chapter? We need to understand the diode operation and select diodes for various applications. We need to use graphical load techniques to analyze nonlinear circuits. Maybe we will not cover this. Analyze and design simple voltage regulator circuits. Use ideal diode model and piecewise linear models to solve circuits. Understand various rectifier and wave shaping circuits, and understand small signal equivalent circuits. We will not talk about small signal or graphical loads. We'll talk about circuits, just circuits, okay? So what is the most important major application of the diode? I can tell you now, very quick application. Can I get your mouse, please? No, you don't need. I just want to turn it on. خلاص, turn it. Do you see this?
Yes.
Number حمراء. You see it's the headphones, the remote control for TV, TV buttons, infrared cameras, smoke detector, this camera. These are diodes. Types of diodes. Special type of diodes called light emitting diode. Okay? إشارات. Now, every time you go in a traffic light, try to look at the traffic. This is the old style. The new style is small light, صح؟
فلات. طيب.
لا منقطة.
صح.
دوائر.
ليد.
lid what? Light emitting diode. Light emitting diode. الإشارة الخضراء أخضر، الأصفر في الأحمر. So light emitting diodes are special diodes that have the capability to release some light, okay?
Without heat
If you apply low voltage, small current, there will be no heat, so you can touch it. But as any circuit, it should have some sort of heat, okay? التانينج، الأجهزة التانينج اللي في الأندية. ما بقول أجهزة الليزر، بس light emitting diodes are everywhere. TV screens, some of it, يعني, they have the same concept. You pass current, you emit light. So let's talk about it a little bit. So it is a two-terminal device. What do we mean by a two-terminal device? It has two terminals, the anode and the cathode. كرون في الفيزياء المصعد والمهبط. Did you study anode and cathode in physics?
Yes.
If you have chemical plate, you put two plates, and then the chemical conducts electricity, you connect it to a battery. The positive, we call it what? Anode. The negative, we call it? I think chemistry 102, they talk about it. Anode and cathode, okay? Same concept here. In the lab, the white strip indicates the cathode. So you cannot connect it like the resistor. It's like the capacitor. Negative is negative. You have to connect it that way. The voltage across the diode is V sub D, okay? V sub D. And is reference positive at the anode side and negative at the cathode side. The diode current is ID. It enters from positive to negative, okay? So that's the first thing I want you to know. So how the diode, okay, what the diode looks like. I'm not going to talk about this now. I will talk about how the diode is manufactured. We all familiar with silicon, right? So how many outer electrons in the silicon? 4, right? You agree with me?
Yes.
جدول الدوري. Am I right or wrong?
Yes.
So let's say we put silicon here, put silicon here, we put silicon here, we put silicon here. What do you notice? Every two adjacent ones, they will form a bond. Chemistry. Otherwise, electrons will be flowing. Silicon, 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 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So because they form bonds, this device made of silicon will not conduct electricity. So even if you apply a voltage here, let's say 0.5 volts, relatively reasonable voltage, the electrons, they are tied together between every two molecules. Okay? So 151 years ago, those smart people, they said, okay, let's add some other material, okay, where it could be anything that has 1, 2, 3, 4, 5. What will happen? You will have a free electron, right? شوائب. هذه اسمها الشوائب, impurities. Some of the materials that they have impurities, I don't recall the name now, but we will watch a video that will tell us what's the name. But the idea here is, once you have those impurities, if you apply a voltage, this is positive, this is negative, the electron will go to the negative side. In a larger scale, current will be moving. Okay? This side, where it has free electrons, we call it N. And here we put other impurities where they have only 3. So basically, one of those electrons will be free. It means there is a hole here, a positive electron that is free, that will be moving toward the positive direction. And this is what we call it the P junction. Okay? I'm trying to explain a very simple concept. Because some of the impurities here, they have free electrons. And some of the impurities here, they have free holes or positive electrons. You will, if you apply positive and negative, the whole, the electrons will go to the negative, the holes will go to the positive, so electric current will move this way. Okay? Okay? Holes will move to the positive, electrons will move to the negative. Something like that. But let's watch a video that talks about it.
So doctor, we just made this to provide a current.
The idea here is you want to break the silicon feature that has stable electrons by having impurities where the electrons will move. I think I reversed the polarity here. I think it should be. It should be positive and negative. Now the electrons will go to the positive, the holes will go to the electrons. But let's watch the video. Was it this video?
قدام.
Okay, I think it's better to watch it here. This is a better. Why there is no volume? ما في كلها أكيد ما في.
كان محطوط صامت يا دكتور من الجهاز.
So we have the anode and the cathode. We have here P-type, N-type. Then they put the resin, which is the black material with the white strip, okay? So as I told you, the silicon has, imagine everything is made of silicon. It has 8 adjacent cells, not 4. Well, 4 are free. So they form bond together, so nothing will be moving if you apply a voltage. This is, we call it the covalent band, okay? So N-type, you put this material, phosphorus, that has 5 free electrons. So what will happen if you have 5 free electrons? Now you can change, you can add 3, you can add 8, it doesn't have to be phosphorus. Then you, on the other side, so this is what will happen. On the other side, this is aluminum. The aluminum material, it has 3 free. So you will have 3 holes. The black dots. Okay? So this is P-type. It has more positive electrons than negative electrons. Here holes for electrons. Here we have more electrons. And they stay like that. Then a depletion region will be created where some of the holes will move toward the electrons because they want to,
Positive and negative.
and then some of the electrons will be connected. So this will be an empty region. So holes are positive, electrons are negative. Now here we'll have more positively charged, here more negatively charged. They will create what we call electric field, المجال الكهربائي, and that is calculated to be 0.7 volts, automatic. Now you apply a battery, and you put the positive here, and the negative here, so the electrons will be moving here, and it will act like a short circuit, okay?
Doctor, what's the benefit of the closed diode?
Close what?
Diode.
Block the current. Sometimes you want to block the current. Close diode يعني short circuit.
يعني قصدي إنه مو بلايت مو بليد.
Its benefit is to control the signal. You don't need to waste energy in terms of lights. That's the benefit. So, as I told you, the depletion region, is it moving? Yeah, it's moving. So when we apply positive here and negative here, the electrons will be swimming. When the electrons swim, electric current will move as the holes moving, okay? This is only if you apply a voltage higher than 0.7 volts. Yeah, in the anode it's positive, in the cathode is negative. But that's the idea. The idea here is you want to destabilize this electric field region. You want to overpower it, okay? If you reverse the direction, you will make this region even larger. So you will not allow any current to move. That is the basic principle of diode. 80% of engineers cannot explain it. Electrical engineers. Okay? So you know what is the diode? Well, I prefer not to continue more talking about features because we have 10 minutes left, but let's try to understand some terminologies. Forward bias, reverse bias region. So this is the forward bias region, this is the reverse bias region, and this is the reverse breakdown region. Let's look at this curve, okay? you look at, for example, this curve, here what do we apply? On the diode, we apply positive voltage. If you apply positive voltage, you just need to exceed the 0.7 so that current will be allowed to move. So this is the normal operation, okay? If you apply 1 volt, 2 volts, 3 volts, you still have a high current, so no need to apply higher volts. So in the forward region, relatively large amount of current flow for small voltage. You just need a small voltage to be applied so that enough current will flow. In the reverse bias region, for moderate negative values, yani you do not apply severe negative voltage, the current will be very, very small, negative microamp. But if you apply very negative voltage, you will break down. Yani it's too much for the diode to handle, and this is the reverse breakdown region, and it will be damaged and cannot be used again. So think of this as what? The damage region, okay? So as I told you, in mechanical engineering, it's similar to that valve. Have you seen this symbol in mechanical engineering? Well, think of this as a water reservoir. This is, if you push the water this way, the valve will be open and it will allow the liquid to move. If you push the liquid here, the water this way, it will close it. Get it?
Yes.
That is how the diode works. The last region is the reverse breakdown region. If sufficiently large reverse bias voltage, any negative voltage, reverse any negative voltage, is applied, the high current will also move, okay? And in summary, the diode consists of a junction between two types of semiconductor material. One has impurities for N-type, where you have more free electrons. The other, you will have more free holes. If you don't apply any voltage, nothing will happen, except you will have a very tiny 0.7 voltage here. So if you put a voltmeter and you measure it from anode to cathode, it will be plus 0.7. If you put the positive here and the negative here, it will be what? Minus 0.7 DC. Okay? Once you add the impurities and you apply a sufficiently large voltage, more than 0.7, electrons will be moving in your circuit. If you reverse the direction of the voltage, it will block the electrons from moving. Unless you apply a relatively large voltage, then it will break down. And this is the video that we talked about. Okay? So this was today's lecture. Very simple. I want you to know more about the diode. Watch the videos again. Every time now you traffic, you go through a traffic light, look at those lights and remember that LEDs stands for what? Hatem? Light emitting diodes. Okay? How many of you know what the LED stands for before? So now you know LED, what it stands for. Okay? This is one of the benefits of electrical engineering. Any question?